Hello everyone, welcome back, JavaMentor.net here. In today's video, let's learn about exceptions. So, we already learned about exceptions in the past. We experienced exceptions. And let's try to experience the most known exception, which is a null pointer exception. And that's exactly when we assign null to some variable or field and then try to access some field or some method on that variable. We should experience null pointer exception here. Division by zero is not defined in mathematics and it's not possible, so we should experience some kind of error here, but not null pointer, something else, because both of those values are not null. Okay, let's try to run our program and see what will happen. And our program say cannot read field first name because person is null. So we experienced null pointer exception as expected, but as you can see, program stopped there. So we didn't saw anything regarding this, neither exception, neither result of this. Which means that when exception occurs, program won't continue normally. All lines after that line where exception happened won't be executed. Now we can just comment this for a second to see what will happen regarding this. So regarding this, we will receive arithmetic exception. So it's just a different kind of exception, and it will give you actually a nice message. Division by zero, it's not possible. Okay, can we prevent those kind of things somehow? Let's learn about that. So I created one method that should multiply two positive numbers. But take a note that if someone passes negative number here as a parameter, we should throw an exception, because we don't want to allow multiplying of negative numbers. Let's say that that's our logic for our program. So multiply, this needs to be static, right? You cannot call non-static method inside the static method. That's why we need static there. Multiply two positive numbers, and let's say 4 times 4, that should be 16. And then we try to system out print line that without this. So 4 times 4, 4 times 4, 16. But minus 4 multiplied by 4, we will actually get some result, because multiplying negative numbers is actually normal in mathematics. It's possible, but we don't want to allow that in our program, because maybe we are I don't know, calculating life expectancy, and life expectancy cannot be below 0. So what we would love to say, if a is smaller than 0 or b is smaller than 0, then throw an exception. Throw, let's say, arithmetic exception. And you need to instantiate an object of that exception in the same fashion like in the class. You can even pass some message here. Okay. So now we should, instead of receiving result, we should receive exception, right? Let's see if that is true. It is. Okay, so we see it is true. Arithmetic exception is thrown from this method and we don't see a result. Now, you can imagine that this method is written in some life expectancy calculator class and you worked on this one. And this code is written by your colleague, I don't know, let's say in Great Britain. So he maybe even don't know what's going on here. I mean, if you create interface, he will just see the signature of your interface. He won't see implementation. So in order to help him, you can say here, hey, this method might throw arithmetic exception, right? So it won't always throw an exception, because if method always throw an exception, then there is no point of that method. It's not doing nothing, just throwing an exception. But sometimes it might throw arithmetic exception. So your colleague in Great Britain is writing a main method and he saw this. Whoa, take a look at this. This method will maybe throw an arithmetic exception, and then he calls you on the phone and he tells you, hey, make sure to pass only positive numbers and handle the case when you pass negative number. And you're like, all right, sir, let's handle that. Okay, so we're trying to do something here. Let's say that we try to do something. Try has those brackets in the same fashion like if, else, and everything. Try to do this, but in case that arithmetic exception happens, instead of throwing that exception, please show this message to the user. And then I will write one more command here so you understand the difference. So if we try to run our program now, what will happen? We will go here, we will try to multiply those numbers, we will see that this will be executed. This method will throw an exception, it won't return a result, which means this method is throwing an exception and we are going to catch part. And inside the catch part, we printed this, as you can see. And after the catch part, because we catch the exception, program continues normally. So this is printed as well. Take a note, for example, if we do only this, without try catch block, program ends is never printed to the console, because this interrupts the program and all commands after this method that throws exception all lines are not executed. So in order to continue your program normally, you need to surround this method that is throwing exception with try catch block. And also, if this doesn't throw an exception, for example this way, then we won't even enter catch block, right? We will just go here, okay, everything is fine, exception is not thrown, we are skipping catch part, and okay, of course this method returned result, which is 16, this is done, this is not done, and we continue normally. Now, important thing to notice is that Java is not forcing us to write this try catch block. Why it doesn't force us? Well, can you imagine that you need to surround every single line in try catch block? So every single line that you write goes like this. Okay, divide two numbers and then catch arithmetic and blah 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 and blah blah blah. That will be a nightmare. That code won't be readable. You cannot program like that. For that reason, Java divided exceptions in two big groups: runtime exceptions and exceptions that needs to be handled. So you need to do something about those exceptions. Null pointer exception and arithmetic exception, they're in the group of runtime exceptions. So Java don't force you to do anything about that. So for runtime exceptions like arithmetic exception and null pointer, Java doesn't force you to write try catch block. But take a look at this. I will create one object of a class that is intended for reading from the files. and I will say read from some path. This is an object, right? And something is underlined here. It says unhandled exception, file not found exception. As you can see from the constructor, this constructor, as any other method, because constructor is only a special method, can throw this file not found exception. So if file is not present in this path that you provided, this exception will be thrown. But the issue is that Java is forcing you to do try catch block. So if you just do this, file is not found, everything is fine. It's not read anymore, it compiles. But Java forced you to write try catch block, and that's because this file not found exception is checked exception. You need to check that exception and to catch if it happens. So basically you handled the case when path is not correct, and if this exception happens, this will happen, and then program will continue normally. Now this try catch is one option what you can do with checked exceptions. Let's for a second try this line here. And I will delete here this. So obviously here also you can do surround with try catch, solve the problem with the same text. You can solve the problem with the try catch, but also what you can do is you can say, okay, wall method will throw this exception. So this exception will be thrown from the method. So whoever called this multiply two positive numbers, let him care about that exception. I really don't care about it. So now if you try to say 4 times 4, this will be read and it will say unhandled exception, file not found exception, because this exception is not handled here inside the body, so I need to deal with it now. And I can try here surround with try catch, that's option number 1, or option number 2 is I can propagate to the caller of the main method. So you either handle exception, checked exception, or the other option is to propagate exception like this. And okay, this is obviously propagating runtime exception, but you really don't need to worry try catch or propagating about runtime exceptions. That doesn't make sense. So usually only checked exceptions are thrown from the method and handled in the catch block. And the last thing that I wanted to show you is this is how the structure looks like. So we talked about exceptions there on the right side. Exception is a class that extends throwable class. And throwable is also extended by error. But let's just stay on an exception for a second. So every exception that extends exception directly, that is a checked exception, right? So if you check this one, it extends IO exception, and IO exception extends exception, which means this is a checked exception, right? And if you check arithmetic exception, you'll see that arithmetic extends runtime exception. And runtime exception, you don't need to care so much about them. If you try null pointer here just for a second to go there, null pointer is also runtime exception. So you can see here everything in red which extends exception, checked exceptions, runtime exceptions are runtime and you don't need to handle them. On the other side you have errors, and they are, let's say, very similar to the runtime exceptions in the terms that you don't need to care about them. So you don't handle errors, you don't propagate them using throws keyword, or you don't use try catch on error usually, but they are much more let's say bigger and more dangerous than runtime exception, and That is the most beginner-friendly explanation what is the difference between error and runtime exception. Just one small last thing to say. When you want to propagate exception, keyword is throws with S. And when you want to throw exception, you don't have S here. It's only throw exception. And I hope that you already now know everything regarding exceptions that is important.